Howdy, Cord Campbell here. Today we're going to be installing Icehouse on Ubuntu 14.04. I have already done that on a compute rig that I have in the house. I have about 5 compute rigs that I run OpenStack on. I'll give you an example of one here. This is a container store crate, a large size, and it's got a motherboard. The power supply is below. I've got 16 gig of RAM and an SSD drive on here, 128 gig SSD drive, and then I've got a bunch of GPU cards in here. You don't need those for running OpenStack. Obviously, I mine cryptocurrencies with this particular unit, and I run an AMD 8-core processor in here, so that gives me plenty of compute on board. That would run you all of those components together, including the crate. It's about $650 or so, so it's a pretty good deal. Pretty good way of being able to get a device that can run OpenStack well. So again, I suggest about 16 gigabytes of RAM or so, but you can do it with 8 gig if you like. The machine that I've got running in the other room has already got Ubuntu 14.04 desktop installed on it. I recommend desktop so that it's easier to manage the box itself. When you're local, you have a nice graphical user interface. It's just easier to do that. I do it as well for the mining that I do. The cryptocurrency mining I do requires the UI. To start out, I installed the OpenSSH server here. So did a fresh install of Ubuntu desktop. Ran this command locally on the box, and then I've come in here to sit down on my computer and do the video and do the rest of the steps. So the first thing that we're going to do is we're going to log into that box. Now, because I do this all the time, I'm going to remove the key for that box and then secure shell into it. And type in my password. Now, normally I'll set up my SSH keys on it. I'm not going to do that here. Become root. We need to do all of these steps as root. And then go ahead and install Git. A little bit of a note here, it's fussing at me. I need to do a update, which I did not do when I was installing. Whenever you do the installer on Ubuntu, there's a little box you can check to say to do the update while it's installing. I just didn't do that. And let's try that again. While it's installing, I'll make a note of the fact that I will fast forward through some of these longer installs. Your mileage will vary on how long this will take you to install, depending on the speed of your computer and whether or not you have an SSD drive installed or not. Alright, now I'm going to clone the repo into my directory and change into it. And then we're going to run the OpenStack networking script, which installs a few components that it needs, and then it's going to spit out a configuration file. I have my router configured to use the MAC address of this particular server and give it the same IP address every time, in this case 10.0.1.100. If you're installing multiple compute rigs, you'll want to number those sequentially so you can keep track of them. Okay, so that is done, and now it's recommending that I edit the etc host file, which I will do now. And put a couple of entries in there for a compute rig. That just statically defines those IPs for these hosts. Alright, the next step is to run the server test. And that confirms that this CPU can run the KVM extensions. And now I'm going to do another system update. Alright, now we're going to run the OpenStack setup script. And the Ethernet interface in this rig is ETH0, so I'm going to type that in, and it'll grab the IP address. It's asking me if this is the controller node. Yes, it is the controller node. If that is not the controller node, if I'm installing a compute node, I would simply say no there. It would ask me for a URL, which we'll see here in a second. Now I'm going to type in a password for this. I'm just going to use a real simple password here because I'm doing a video. You should be sure that you pick something that is secure. If you decide to expose this externally to the internet, you'll want to make sure it's secure. And yes, this is a multi-node install. It's going to give me a URL, which you'll want to copy and paste that somewhere safe. And now we're going to install the MySQL server. And right after I install the MySQL server, I'm going to install do the Splunk deployment. Okay, now we're being asked for that password again. And this is actually setting the root user for MySQL. So you want to make sure you type in that password that you picked earlier. You're going to enter that twice, and then you're going to do that again here in just a second when it asks for it. Okay, again, same password. And now we're going to be asked a couple of questions about securing the MySQL server. This is a new step in the process. We don't need to change the root password because we just changed it, so we're going to say no to that. And then we're going to say yes to the rest of these questions, which is going to have MySQL go off and do a couple of things to secure itself. And then we're going to enter the password one more time. And it's going to create the databases behind the scenes. And then I'm going to go back now and install Splunk real quick. The reason I'm installing Splunk is so that I can see the errors that are coming out of the system, and later on I can actually monitor the system with Splunk to ensure that it's running correctly. This is useful if, you know, maybe something doesn't go just right with the install, or you know, there's a component that needs to be restarted or something like that, and I'll give you a heads up to that. It's nice because it comes out inside the web browser, so it's much easier to deal with than going and tailing log files. Okay, so Splunk is now running. Now my local machine doesn't know about this particular host name yet, so I'm just going to go in here and change this to the IP address of that box. And then go ahead and sign in. Wants me to change the password. And then I'm going to click on search and type a star. And then I'm going to go over here and select a 5-minute window on the search. And then that'll start looking at what I'm doing on the server and tailing the log files for me, essentially. Alright, so we've gone through the database setup already, so we're going to move on to installing Keystone. Keystone is the authentication system for OpenStack, so it's what all the other components talk to. If you don't have Keystone running correctly, all the other components will fail. Alright, now Keystone has been installed. I'm going to test it. I'm going to source the stackrc file, which contains the username, password, and the project ID for the OpenStack install. This allows you to run commands on the command line, like this Keystone user list command. When that comes back, that you know that you've installed Keystone correctly. If you get an error there, you need to double check that. Alright, so the next thing to do is to run the OpenStack glance installer. This is going to install the image service, which will hold the images that you use to boot off of, boot instances off of. Alright, now Glance has been installed. We can run a Glance image list and get back the images that were added by the script. Now we're going to set up Cinder. Cinder is the volume storage manager for OpenStack, so it creates volumes that you can attach to instances. Alright, the Cinder install is complete. What we need to do now is create a loopback file. Alternately, you could use a hard drive, a separate hard drive for this. In order to do that, you'll need to take a look at the OpenStack_loop.sh file that's in this directory, and you can hack that up and make it work for a physical volume instead of a loopback volume. I'm going to create a 50 gigabyte volume here. This script also creates a storage type called storage, and that's what you see spit out there. Alright, the next step is to run the OpenStack Nova script, and just to give you a little reference, we're down here. We could also run this command cinder create volume type storage. We could create a 1 gigabyte volume. I'm going to skip that step here, and I'm moving on to this OpenStack Nova install. Just keeping the Splunk interface up so that I can watch for errors. Some of these errors that you're seeing over here in the Splunk UI are normal-ish. Make that a little bit bigger so everybody can see it. So I'm going to just note here that you're going to see a lot of errors being spit out from Nova when it gets installed with Aptitude. It starts Nova and then I restart it, and then what happens is then I do a db sync, which creates all the tables. So right now it's running that db sync, which takes a little while, and as a result you're going to see a lot of errors being spewed out into the log files. That's normal. Okay, the last step there was to restart all the Nova services, so we should be able to do a Nova image list. And we got back a list of images, which means that Nova is functioning. Looks like our logs look okay. We're still going to see a couple of Oslo errors every once in a while. I still haven't figured out what's causing that. The last step is to install OpenStack Horizon. And then we have one more step after that where you need to add the network. Alright, so Horizon is now installed, so we should be able to pull that up. Before I do that, I'm going to run this Nova Manage Network Create command. And what I did here is I essentially created a network which is 10.0.47.0. You can add whatever network you want there. That should be a private network. A little bit about the routing. So this is, I have a ASUS AC66U router running the latest firmware, which also supports IPv6. And what I've done here is I've added the network 10.0.47.0, and I've pointed it at the box that I'm on. So this box is 10.0.1.100. And I've created a static routing entry so that my router knows how to get to that network from the rest of the network here at the house. Alright, so the last thing I want to do is go and open a tab to Horizon. I'm just going to paste that in here. And I want to use the password that I picked earlier, which in this case is foobar with zeros. And then I'm now logged in. I'm going to shrink this just a little bit. So just to kind of like go over this real quick, so there's a new overview. You've got a list of hypervisors. I would note that this QEMU hypervisor entry here, what happened is they took KVM and QEMU and put them in the single project. So what QEMU will try to do when it launches an instance is to see if it has the extensions for running native KVM virtualization on the box. If it does not, so if it's like on a VM or maybe a DigitalOcean droplet or something like that, if you're just installing this and trying it out on something that doesn't support hardware virtualization, it will also be able to start those as well. So there's no extra configuration that you need to do. It can be a bit confusing though if you're running on a box that does support it. but if you look at the process list after an instance is started, it will be running as a KVM instance. So now I'm going to launch an instance. I am not going to create a key pair, but you'll want to create a key pair here if you want to be able to log into the instance. So I'll call this test. I'm going to pick a small instance. One thing of note on a tiny instance now is that it only has a 1 GB disk attached to it. So I don't recommend using the tinies, or perhaps you would like to edit the tiny so that it has a bigger hard drive. If you launch like an Ubuntu instance on this, it's not going to work. It's going to fail. So I'm going to do a small, and then I'm going to say boot from an image and select the Ubuntu precise image that I pre-installed with the script, and then click on launch. I'm not sure that I'm totally in love with that UI now. It's a few extra steps now to be able to launch an instance, but overall I like the new UI. It's clean and it has more information packed into it. You know, we're not seeing some stuff here, so we don't have Swift installed, so we're not seeing the object store entry. We also do not have Neutron installed, which is the networking project, because we've done a flat networking bridge with the kernel. And so we're not going to see any network interfaces here. That's by choice, because it's much easier to deal with the networking aspect of OpenStack when it's simple. And usually use cases don't require a lot of complexity with the network. If you'd like to get into that, there's some other resources on the internet for that, but I don't really mess with the Neutron networking stuff. It's just too confusing and too hard for me, at least. That takes a minute to spawn, so we'll just kick back and wait on that. So one thing that I'll note here is that when this box comes up, we will need to have some security rules in place that we can ping it. And I'm going to add a rule for all ICMP, and just click on that to add it, and then add HTTP, which is port 80. And then one final rule for SSH connections. That will allow all hosts to connect via ping port 80, the web services, and port 22 to be able to secure shell in. We're going to go back and look at our instances, click on test here, and click on the log. And we're still booting here, so it's in the cloud init section. Alright, now the instance is done booting. We can pop over and open a new tab and hopefully ping that instance. And there you go, we're pinging it. If we click on the console, we can see the login. So if I had SSH keys that I had injected into this instance, I would be able to remotely log into it. So that's it. That's the new Icehouse. It looks pretty good. We've got some nice graphs up here showing usage, and hopefully this will get you going on the latest version, and you can start looking at using OpenStack for deploying your production applications. If you have any questions, be sure and either email me. I'm cordless@gmail or cordless@stackgeek.com. I'm also on Twitter at cordless, KORDLESS, or @stackgeek. Take care and have a great day.